Hi Rockridge, this is Megan Berger, returning on a lesson about imaginary numbers, powers of I, and rationalizing imaginary denominators. So in our last discussion, we talked about the number systems and properties, and we alluded to imaginary numbers. Today we're going to find out how those imaginary numbers work together. So let's first define this number I. I is what we call the square root of -1. We've never seen square roots of negatives before. We've always kind of left them alone. These are actually imaginary numbers. That's what we call imaginary numbers versus real numbers. Okay? So if any number has the component I, or the square root of -1 in it, it is imaginary. Think about what would happen if you took the square root of -1 and squared it. What would happen if you squared that? You would end up with -1. Okay? So these facts, we need to make sure we have nice and straight in our heads. And we need to think anywhere I see I, that's going to remain I, square root of -1. But any time I see I squared, I may replace that with a -1 and continue with my simplifying. And we always need to replace an I squared with a -1 as we go through our work. It's a very useful tool. Again, we discussed this last time. The standard form for complex numbers is some constant plus another number times the imaginary component. So this has 5 as the real component and 2i as the pure imaginary component. And together that's your complex number. Pure imaginary is when you don't have this a component, when you just have 3i. That's pure imaginary. And of course you can see how our little joke plays out now. Always think of the square root of -1 as the letter I. And of course, I love math, as I'm sure you do too. Powers of I, there are a couple of ways we can work to determine the simplification of powers of I. I would like to discuss the chart toward the bottom here first, and then go back to the circle. So there's a pattern that unfolds with these powers of I. So follow with me as we walk through this pattern. I to the 1 power is I squared is -1. We just discussed that, right? I to the power of 1 is I squared is -1. I to the 3rd power, if you can remember your power rules, whenever you have a 3rd power, that's the same as the 1st power plus the 2nd power. So that's actually multiplying this times this, and it's -I. So I to the 3rd power is -I. I to the 4th power is basically I squared times I squared, so that's -1 times -1, and so that's 1. And so this pattern repeats every 4 times, every 4 powers. So the pattern is I, -1, -I, 1. I, -1, -I, 1. This pattern repeats every 4 times, and so if we can find out how many times we run around this pattern of 4, and then find out what the remainder is, we can then go back and say, all right, whatever that remainder is will get me down to the correct simplification of this power of I. Let's take a look at this example, I to the 87. 87 divided by 4. 4 goes into 8 twice, leaving a 7. 4 goes into 7 one time, with a remainder of 3. Therefore, I go around this pattern 21 times, right? There are 21 groups of 4 that I go around with the power of 87, 21 times, and then I have a remainder of 3, so I go the 21st time I hit this, I then go remainder of 1, 2, 3. Therefore, the simplified version of I to the 87th power is -I. That's how that works. That pattern repeats itself every 4 times. Another way you can remember this is if you were to take that power and divide it by 4 in your calculator, it would spit out a decimal, right? So 87 divided by 4, if we keep to our example of I to the 87th power, 87 divided by 4 on your calculator, what does that leave you? That leaves you 21 point what? Is it 21.75? anything that divides it by 4 and leaves you a 0.75, you know that that simplifies down to negative I. So that's how you can use this chart. If you would like to memorize this circle, that anything with a 0.25 decimal after dividing by 4 simplifies down to I. Anything with a 0.0 decimal simplifies to 1. Anything with a 0.75 decimal after dividing by 4 simplifies to negative I. And anything with a 0.5 decimal simplifies to negative 1. You can certainly memorize this circle as well. That will help you with these. So let's look at a few examples to help practice this skill. Using whatever method you like. I squared, we shouldn't even have to go through our little chart. We should always remember that I squared is negative 1. So please always have that in your mind. I to the 8th, though. My favorite way to do this is to divide by 4. If I divide 8 by 4, it goes nice and evenly with no remainder. And so since that goes to 4 with no remainder, I know that on this pattern, it is 1. I went around 4, 5, 6, 7, 8, no remainder, so I end up with 1. So that simplifies to 1. I to the 11th, however, well, 11 divided by 4, if you're doing it in your calculator, you should still get that it goes in 2 times. And you have 0.75 on your calculator, or a remainder of 3 if you're doing it by hand. And we know that with a remainder of 3, we go around and we have a remainder of 3, so we go 1, 2, 3, negative I, or negative I here on your circle chart. So this simplifies to negative I. So these are what we want you to write as your simplified versions of these powers of I. 46 divided by 4. If I get 4 into 6, I get 1, and I have a remainder of 2. A remainder of 2 means I simplify down to negative 1. 101. And if you're doing this on your calculator using the decimal method and the circle, that's completely fine. Just choose a method that works for you and stick with it. I like the dividing. So 4 into 10 goes twice, with a little left over 2. Bring down the 1. 4 into 21 goes 5 times, with a remainder of 1. If I have a remainder of 1, that means it's I to the 1 power, which is just I. Okay. And then finally, I to the 15. We divide 15 by 4, since that pattern repeats itself every 4 times. 4 goes into 15 3 times, with a remainder of 3. What happens with remainders of 3 or 0.75s? They are negative i's. I to the 3rd is negative I. All right? So that's how we do powers of I. Now let's manipulate and add, subtract, and multiply these imaginary numbers. So let's look at these 2 complex numbers here that were given in number 7. These work very similar to how we did variables in Algebra 1. They work very similarly. We can combine, so if this is the number 8 minus I plus 5 plus 4i, you can combine like terms. The 8 and the 5 are alike, and so that's 13. And the negative I and the 4i are alike. Negative 1i and positive 4i means I have a total of positive 3i. So that's how we simplify those complex numbers. We gather together the like terms. In number 8, we use the distributive property, much like we would if this was an x instead of an I. We distribute the 3 here to the 5, and we distribute the 3 to the negative 4i. So we get a 15 minus 12i. Okay? And that's it. In number 9, we have a 4 times this complex number minus a 6 times this complex number. So let's distribute first and then combine like terms. So let's distribute the 4. So let's make that a 12 minus an 8i. Let's distribute this negative 6 to make a negative 48 minus 6i. Now that we have everybody distributed, we can combine like terms. The 12 and the negative 48 are like terms, so that's a negative 36. And the negative 8 and negative 8i and negative 6i can be combined for a total of negative 14i. And that's your final. All right? So they work very similarly to how you would think they would. Let's continue with some more examples. Number 10, again, is a distribution, but let's look and see what happens here. Let's distribute the 6i to each of the insides. 6i times 3 is 18i. 6i times positive 3i is 18i squared. What did I say we need to do every time we see an I squared? I said we need to think of this as a negative 1. Now please be very careful when you're doing this. Right now 18 is being multiplied by an I squared. This is 18 times I squared. So let's not forget that this is an 18 times a negative 1. When we replace this I squared, we're replacing it with 18 times a negative 1, okay? So don't subtract that 1 from 18. We are multiplying. So the simplified version of this is 18i. And what's 18 times negative 1? That's negative 18. Okay? Anytime we see an I squared, we must replace it with a negative 1 and make use of that. Number 11 works, again, very similar to what we did in Algebra 1. We FOILed. Do you remember FOIL? First times first, outer times outer, inner times inner, last times last. That's what happens when we're taking two binomials and multiplying them together. So let's go ahead and carry that out. 2 times 3 is 6. 2 times negative 4i is negative 8i. 5i times 3 is positive 15i. And be careful here. 5i times negative 4i is negative 20i squared. Be very careful there. We are going to replace this I squared with a negative 1. So this is going to be a negative 20 times a negative 1, okay? So let's gather up our constants. We have a 6. You're connected to an I, and you're connected to an I, so you can't combine with the 6. 6, and this negative 20 times negative 1. What does that become? Negative 20 times negative 1 will become a positive 20, right? So let's combine this 6 with this 20, and no one else. Negative 8, you're connected to this I. 15, you're connected to this I. You cannot be combined. You are not a like term with this 6. 6 and 20, you guys are like terms. So let's make you 26. And now let's gather the I's together. Negative 8 of them plus 15 of them. That's a total of 7i. So that's the simplified version of that. 12 is very similar. First times first, outer times outer, inner times inner, last times last. First times first is negative 36. Outer times outer is plus 63i. Inner times inner is plus 8i. Last times last is negative 14i squared. Don't forget, you will be replacing that I squared with a negative 1. You're going to be multiplying that negative 14 times a negative 1. So take your negative 36, do not combine him with 63. That 63 is locked in arms with this I, so they're not going to be separated. So they're not like terms. So the negative 36 gets combined with, what is it over here? Negative 14 times negative 1, that's a positive 14. So negative 36 plus 14 is negative 22. Now let's combine our i's. 63 of the i's plus 8 of the i's is a total of 71 i's. Okay? Be careful on 13 as well. Notice that this negative outside here means we're basically distributing a negative 1 to everything on the inside of this parenthesis. So I highly recommend you do that first. Let's make this a 10 minus 6 minus 7i plus 4i. Now you can combine like terms. The 10 and the negative 6 are like terms. the negative 7i and the 4i are like terms. So 10 minus 6, that combines to be a 4. Negative 7i plus 4i combines to be a negative 3i. 14, another distribution problem. Distribute the 4i to both terms on the inside. Negative 24i is the first term, and positive 4i squared is the second term. What do we do with I squareds? We replace them completely with negative 1s. So we need to think of this as negative 24i minus 4, right? Because 4 times negative 1 is negative 4. Don't forget, we are replacing this, therefore we are multiplying negative 1 times the number that came before. Number 15 is another binomial times a binomial situation. So let's first times first, outer times inner, last times last. First times first is 9. Outer times outer is negative 12i. Inner times inner is positive 12i. And last times last is negative 16i squared. Immediately you should notice that the negative 12i and positive 12i cancel. That's very useful. We're actually going to use this situation a little bit to help things get a little simpler. Now we're left with a 9, and what did I say we needed to do with this I squared? We need to completely replace it with a negative 1. Negative 16 times I squared, or negative 16 times negative 1, turns into a positive 16. 9 plus 16 is 25. And there's no I components left, so we're simply left with a 25. Notice what happened here. 3 plus a 4i times 3 minus a 4i meant that the inner terms cancel, and we're left with a real number. We had two complex numbers with imaginary components, and now we have a real number. We're going to make use of this in rationalizing the denominator. Rationalizing the denominator means making the denominator rational. Remember our number systems, when we categorized numbers into the different systems? If you've got an imaginary number, we're going to make use of the thing we just did in the last problem to make that denominator rational. This is a simplification step that we need to do. Why do we do it? We do this to represent mathematical expressions in a different way. We're rationalizing the denominator to practice our skill of representing mathematical expressions in a different way. We're going to practice this skill and make use of this part of our brain. So let's review again. If we were to multiply 2 plus I times 2 minus I, let's watch the magic happen again. This happened on example 15 above. We're going to see it happen again here. Let's FOIL this. 2 times 2 is 4. 2 times negative I is negative 2i. 2 times positive I is positive 2i. I times negative I is negative I squared. Let's cross out the terms that cancel each other out. Let's replace I squared with a negative 1. So now we're looking at a 4 minus a minus 1, or a plus 1. 4 plus 1 is 5. Again, we started with two things that had imaginary components, and we resulted in a rational number. We have rationalized this. The term we use to describe 2 plus I and 2 minus I is the term conjugate. 2 plus I and 2 minus I are conjugates of each other. They are the same binomial, with the opposite sign between. or anything else you need to remember that by changing the sign in the middle, you're creating the conjugate. Do not change the sign of the first term. Only the middle, only that last term changes signs. These are conjugates of one another. We are going to use conjugates to rationalize denominators or make denominators into rational numbers. So let's see what that looks like in the group practice. So the first one, this denominator is not a rational number, right? This is not a rational number. But we can make that denominator rational by using the conjugate. What is the conjugate for 1 minus 2i? Hopefully you said 1 plus 2i. We changed the sign of the middle. Now, to keep this fraction as the same fraction, we need to not alter its identity completely. We need to multiply by whatever we multiply on the bottom, we have to do to the top. Okay? We cannot change the chemical makeup of this. We have to multiply this by, basically, we have to multiply this by 1, right? Because these cancel. But we need to rationalize the denominator. This will result in a bit of a messy numerator, and that's fine. Messy numerators are fine. We always want to make the denominator, however, a rational number. All right, we've chosen the conjugate. We've multiplied the denominator by that conjugate, and we've multiplied the top by whatever we multiplied the bottom by. So let's go ahead and carry this out. 1 times 1 is 1. 1 times 2i is positive 2i. So the top is that messy thing. The bottom, 1 times 1 is 1. 1 times 2i is positive 2i. 1 times negative 2i is negative 2i. Careful on this one. Negative 2i times positive 2i is minus 4i squared. Doesn't look pretty yet, but we know it will, won't we? These cancel, which is what we were after. Replace I squared with a negative 1 so that this becomes 1 plus 2i on the top. And what on the bottom? Let's think about this. 1, negative 4 times negative 1 is positive 4. So 1 plus 4, that's 5. Check it out. That's rational. We have rationalized the denominator. We are not after making the numerator very pretty. It's kind of the victim to whatever we chose to do. We have victimized the numerator, but that's fine because our goal was to simplify by rationalizing the denominator. Number 2, I would like you to first think of number 2 as something that's more simple than what we have here. Let's think of this first as, what's the square root of 16? That's 4 over 4i. I see something we can simplify again. This 4 and 4 can turn into 1 over 1i. So now I've got 1 over I. I still have something imaginary in the denominator, which I never want to have. I must rationalize this. I must make this into something that's a rational on the bottom. There are several things I can choose to make that happen. The most simple thing, because we don't have a binomial on the bottom, because we don't have 2 terms on the bottom, we could easily make this rational by just multiplying it by I, right? If I multiply I times I get I squared, which is negative 1. So this step is even easier than what we did in number 1. We don't even have to come up with a conjugate. If you were to choose negative I and do a negative I over negative I, that will work out just the same as long as you keep simplifying. But the easiest way to take care of it, if there's just a simple, pure imaginary on the bottom, is to multiply by I over I. Whatever you do to the bottom, you must do to the top. So let's see how this plays out. This was reduced down to the number 1. So 1 times I is just I. I times I is I squared. What's I squared? Well, that's negative 1. Therefore, I divided by negative 1 is just negative I. Okay? Number 3, we get back into conjugate land. So let's go back to the conjugate land. What is the conjugate I'm going to use to rationalize this denominator? When I came upon this, I said, oh, you're not a rational number. I need to rationalize you in order to simplify this. I'm going to choose what as my conjugate. 4 plus 5i is my conjugate. Whatever I do to the bottom, I must do to the top. If I chose 4 plus 5i to rationalize my denominator, I must make the top the victim and do the same thing to the top. Now let's multiply. Let's do the top first. Distribute 3i into our conjugate here. 3i times 4 is 12i, plus 3i times 5i, which is 15i squared. Careful on that. And yes, we will be addressing that I squared in a moment. Let's FOIL the bottom. 16 plus 20i minus 20i minus 25i squared. Please be very careful with these. All right, let's cross out the things that we know cancel. Let's think of these I squareds as negative ones and keep simplifying. So what does this top become? 12i, and then we've got a 15 times a negative 1. So let's make this 12i minus 15. And now I've got a 16 and a negative 25 times a negative 1. So that becomes a positive 25. So positive 25 plus 16 becomes 41. I'm going to make this a little clearer over here. So our final answer is 12i minus 15 over 41. And now that my denominator is rational, I can finish. It doesn't matter that the numerator isn't terribly pretty, that's fine. My denominator has been rationalized. That was the goal. All right, go ahead and attempt your independent practice.